Hey, hello. Lately, I got a lot of requests from outside YouTube in the real world, but also inside YouTube to continue with my general Grasshopper tutorials. And my approach is that I will try to explain not just one design kind of script or a script which creates certain things, but the idea is to provide a general knowledge of that software. In one of the last scripts, we talked about how to divide curves. That was quite exciting. This time, we take it up a notch and we talk about attractors. Are you attracted? Before we jump in, we have one new member and one rejoiner, which is absolutely amazing. A new member, Kimi On. Absolutely fantastic that you joined. You joined the team. Thanks for your support. Amazing, you have only 3 subscriptions and 1 is me, my channel. There's nothing really special you get out of the membership except that I will prioritize your questions. Rafael F. Giaretta rejoined 6 days ago or 7 days ago. It's quite amazing. So yeah, Kimi On and Rafael F. Giaretta. Thank you so much for this amazing support. All right, let's jump into Grasshopper, Rhino and Grasshopper. And what we trying to create is something like this. We're creating a grid with circles, and we have a point which we can move, and that influences the radius of these points or these circles. It's a simple script. It's not, as you can see, it's not very big. But it again explains quite a lot of how Grasshopper works, and you get a lot of fundamentals out of this. All right, let's have a start. I will just completely delete this and we start from scratch. All right, let's have a point. We're starting with a point, and I will use a method which is a bit older than the usual. There are already tools which probably can create things faster, but I want to make sure you get the fundamentals right. You understand the fundamentals of Grasshopper. All right, we have a point. There's nothing special about it. We can take this and set one point. I will just click this one here. I created a point before in Grasshopper. Now this is referenced here. Again, with right click, you can set one point. Now, last time we created points by dividing a line. This time we creating our points from scratch. We're creating our points from scratch, right? That's what I wanted to say. Last time we had the curve, and we divided the curve that gave us this kind of points along the curve. This time we create points from scratch out of one point. And how does it work? So there are, again, here on top, you have your parameters, math, domain, matrix operations, and so on. And then we have sets. Sets are really important to understand because they tell you a lot about they're fundamental to Grasshopper. And some tools they use them in the background as a shortcut, so you don't actually see what's happening in the background, but they're everywhere basically. So what are sets? Now, okay, I can go here and go into sequences. I can create a sequence. That's pretty exciting. So for example, or a series, let's create a series. In here are different objects again, but let's just take this and let's create a series. Funny thing is there's no input for the point, of course. So the point, we need to do something. And last time we used a tool called move. Let's get this also here so we can talk about this together. Move. Or you can double click here and type move. And you see this here. Oh, by the way, yes, bifocals. I put the bifocals here, then it's easier for you to follow. Point, move, series. You're gonna ask yourself, what does he want? Okay, I want to move the point. I want to make copies of the point along a line or along a direction, and in that case, the X direction. So from last time, you know that we can move things and it automatically moves somewhere, right? So we had this. If I go back here into shaded mode, we moved the curve, or we moved points, and that went along a certain vector, the translation vector. And now, but I want to move things in plan view. So let's go back to plan view. In plan view, I want to move it in x direction first. So I get a vector which is called x, the unit vector x, and I place this here. Now this moved basically from 0 to 1, because here's 1, from 0 to 1. So we have this original point, and we have a copy of that point here, and the moved point, which is the output here. I could also hide this and now have my original point and my moved point. So the unit vector really is just 1. In that case, it's just 1, 0, 0. So 1 in x direction and 0 in y direction, 0 in z direction. Now the input here is just 1. But what if I have more than just one input here? So I could, for example, here put 1, and then I could, this is my input. Now if I click here, very important, this is already special knowledge. A lot of people don't know that. You can also put here multiple data. If I click here multiple data, then if I click on top of this and put the second here, or let's say 10, let's say 3, 2, and 4, and 6, then I have a list, and you can see that my point was not just copied to 1, it was copied 2, 4, and 6 distance. So it was copied from 0 to 1, 0 to 2, 0 to 4, and 0 to 6. Now with this tool, the series, I can create a series of numbers. I have a start point, I can generate the start point, and I can generate steps, the step size for each number, and the count, how many numbers. So I can place here step size 0.25. Let's make this different. Let's go here and say between 0 and 1. Now 0 doesn't make much sense, so we place here 1, and step size maximum 100. Now we can't see any, we don't know what's happening inside, but we can see that there's an output here. So this tool basically creates a list which starts in that case from 0 and has a step size of 30. So it goes 30, 60, 90, 120, and so on. And now I can place a count. Maybe let's make this a bit smaller and say maximum 10. Maximum is 10. Maximum is 10. But then I can have the count of the numbers. How many steps? And that I make bigger. So I can go here from 1 to 100. And you can see it all in here. Now that is the same as I showed you before. It's a list of numbers. And it can place it in here. And now I have copied all these points along the x vector. I can close this, don't need this anymore. I can just make the step size smaller and the amount of steps less if I want. Now, imagine I want to make a grid. You probably notice, if you're familiar with computer programming, Python, then loops, it's gonna be your friend. But let's say I want to make a grid. So what would I do? I could now move all the points I created. These are my new points. Plus, okay, maybe I just get rid of this one. These are my new points. What I could do now is to move them again along a vector. In that case, I want to move them along the y-axis. So I can double click and say y, unit vector y, and I'm gonna copy this here because I want to move them, and I want to move this result points. The result points are this one, and I want to move it by the unit vector y. Now if I do this, I can see okay, now already we have, because here's written 1, it's moved already one step. That's pretty cool. Now I can take the same series, because if I want to have a grid, I could take this. Let's do this. Okay, so I take this and copy it and place it in here. Now that makes something very different now. It's a bit strange. Why is that? That has something to do with how the data tree is organized. Now you think, oh wow, what is a data tree? All right, okay. If I would have here only one number, let's get this away. Okay, let's disconnect again. Here I have a list. I have a list of points, right? and here I have one number. Now what it does, it takes the list, basically the whole list is moved by 1. Imagine this is my geometry. The geometry is my list, is this points. It's not just 1 point, it's 29 points, and they are moved by 1. Now, if I put a series, opera, that was not what I want. So if I now instead use a series, what it does, it actually moves the first point by 0, the second by 3, the third by 6, the fourth by 9, and so on. That's why it generates this one. Generates like this kind of 45-degree direction. That's of course not what we want. We want to basically do the same what we did before, copying this 1 point along the whole series. How to do that? Okay. By crafting it. So, and you can either do this, you could do this in 2 different ways. So one is if I flatten this here. Flatten means it's a very simple list. Let's look at this again. In here is a list of vectors, and it's just affecting the y coordinates. Beginning is always x, then the y coordinates and the z coordinates. That's a simple list, and that translates into the simple list, which are these points. These the current coordinates of the points here below. As you remember, if I click this here, you can see this, these are the points. By crafting the unit vector or the points, I can also craft the points. So I can also go here and say craft. What it does, you can see it automatically here. It creates a separate list for each point. And now each list is moved by the series of the unit vectors. So maybe I'm gonna show this a bit different, that you can understand it better. Sometimes I cannot find the stuff. Okay, now I found it. This tool is quite useful here. Parameter viewer. Place this in here. It's almost like the list before, but I can draw a tree. I'll go back here, and now you can see if I don't do anything with the points, this parameter viewer shows me that there is one list containing all the points. That's what it does. That's what it shows. You could also simplify this. It doesn't change anything because it's already the simplest version. But if I can also go in here and have a look. This is the same. So this is a list of unit vectors. It's one list. That's why here's 1. The same with this one. Now there's only this moved geometry in here. But if I craft this, then I create from that single list, I create a list for every individual point. And that allows me to create this grid structure. And this is actually the hardest bit of the whole thing. The attractor is simple. Now I have this moved geometry. I've created a grid. I turn everything else off. This is my base. This is where I base everything off it. What we can also do, currently this point is locked to this point in Grasshopper, in Rhino. We can also internalize the data, then it makes it fixed and it's inside Grasshopper. We can internalize geometry inside Grasshopper. Or we can create this point from scratch without any Grasshopper, without any Rhino interaction. For that, we could create this point here. It's called vector construct point. And if I use this tool, actually there's already a coordinate in there. So I could use again X, Y, and Z coordinates. In that case, these would be just simple sliders. And the output is a vector. In that case, it's 0, 0, 0. That could be going here. And that's my vector. Sorry, that's my base point for this script. Now this point here is actually detached. It has nothing to do with the script anymore. But I could put a slider and move the slider along. And I could also, of course, slide it in the y direction if I want. But now that's the fun part. First, let's create a circle. Very fancy, a circle. Creating a circle, and we want to apply the circle to all these points. Now we have our points in here. These are all the new points. And If you now put this in here, it creates a circle for each of these points, and it has a radius. The radius is 1. Now what is an attractor? Attractor is a point which kind of works like a magnet almost, and it's actually a very simple concept, but it has loads of very amazing, interesting possibilities. So I could, again, either generate a point like we just did. That's an option. Or I use this point. Since I have it already here, let's use this point. I'm gonna set one point. This is my point here now. And I, of course, can call it Attractor. By the way, you can also group stuff by Control G. Control G, you can group things. In that case, it's not a group, it's just one thing. But this can be named, which is quite handy in that case. A bit annoying now with this attractor and the point on top of it, but you'll see it will get better immediately. In that case, yeah, if I turn off the bifocals, then it would make more sense. Then you can see it. I'll go back because we want to know what we're doing. You get the concept. Now I could also turn off this here, so I only see my circles. Now what I can do in Grasshopper is something really interesting. I can measure the distance between this point and all the other points. So let's do this. I type here distance. I use my attractor's point A, and all the geometry is point B. And let's have a look again on our data tree. I want to make this simplified, so I go here and make one list. Again, I just want to have one list. That's what I want. And actually, let's put this in here. So we are talking about our circles. Now you can see that what I get is a list of distances. Now I can use so what if I, instead of using radius 1, I could use this list to define my radius, because I have the same amount of distances as circles. Pretty cool. What I want to do here though is I want to maybe have a bit less. Let's shrink this a bit, and I have my point here. I'm gonna also hide this one so it's not that confusing. And now instead of using 1 as a radius, I use this list of distances as my radius. Okay, that's of course not what we want. And now, of course, the math geniuses among you guys probably know this can do much crazy stuff now with this, but I will just keep it super simple. I will just use a multiplication here from the math operators, and I put this in here. Now nothing happened, but I can again use a number slider, and I can place this in here and lower this. Wow. I mean, it also looks pretty cool like this, but we want to have something like that, of course. That's pretty much it. Now if I move this around, you can see the distance of my attractor to the center points of the circles influences the radius of the circles. Don't need this anymore. Now what I want to do as a final step, I want to create a surface from this boundary circles. Just place this in here. Yay. Hide this again. Now I have surfaces in here, and they're red and green. When I touch it, they're green. I can also use a custom preview for this. So I can go in here and have a different color. So I can create here a material which has a diffuse color, a specular, emission, transparency, and so on. And I can go here and add a color, for example, RGB. Oh, no, HSL. Or can even, this is even more, it's more easier to use. It's not cool. So there was a better tool really for this. Let's try this one. Yeah, color picker. I like this one, color picker. All right, another beginner's tutorial. See you in the next video. Ciao.